If you've watched the videos from the last lesson, you would know by now that strings and characters aren't actually stored on the computer as strings and characters. Everything is really just a number. But we don't really use the ones and zeros a whole lot when we're programming. Instead, what we like to use is the Unicode or the ASCII character values. So you can see right here, we've got an ASCII table, and you can see that the letter A, a capital A right here, gets the number 65. So we see the letter A, the computer thinks it's a 65. So the way we can access this number and how it's related to this character is we can just say print, and then we can say character 65. So if we print character 65, you will see it prints out a capitalized A. Now the opposite of that, like let's say we didn't know what number A was, but we wanted to know what number it had, we could say print ord of A. Now if I run this right now, it's going to give me an error, and that's because A, it's thinking you want to know the ord of variable A, so we have to put A inside these quotation marks. So when we run it, it says print character 65. Well, it looks on the table, okay, character 65 is an A, so it prints an A to the screen. Print the number that's associated with the letter A. Alright, the number that's associated with the letter A is the number 65. So character prints out the character of a number, the Unicode number that's given, and ord returns the Unicode number that is assigned to that character. So these are the inverse of each other. So here's an example where we're using ord on 4 different letters. And when I run it, you can see that J is number 74. That's a capital J. Lowercase o is 111, S is 115, and H is 104. So we can print out each character individually, but what happens if we have an entire string? So here's a string, and let's say we want to know what number is associated with each of these letters the whole way through. Well, we should probably use a loop to do that rather than printing out text 0, text 1, text 2, etc., etc. So we could say for letter in text, we're going to print out the ord of the letter we're on. And we don't want to go to a new line every time, so we'll just put a space there. So if we run that, you can see it goes 80, 114, 111, 103, 114, and there's the 114 twice, and that's the PR, P-R-O-G-R. So there's the 2 R's. 114 is the 2 R's, and then A-M-M-I-N-G space, and so on. Now instead of just printing out these numbers, let's store the values. So we could say value equals ord letter, and then now instead of that, we'll just print out value. Okay, so value is just going to be taking on a number, so when we run it, you can see we've got the exact same list that we had before. This is doing the exact same thing. Well, let's take it one step further then. What happens if we print the character for value? You can see it outputs programming is so much fun. Now there's a space in between each letter, and that's just because we put an end with a space here. We can simply do this to get rid of that, and you can see it's back to normal. Now how could we use this information to encrypt this text? Well, remember that value is just taking the number that's assigned to the letter. Well, we could just say value plus equals 1. What that means is, alright, if the number is 111, I'm going to make it 112, and I'm going to print that value to the screen. All of a sudden, if we run it, you can see our text is like some bunch of gibberish. And all we've done is we've shifted everything over 1. Remember it said programming is so much fun. That's a P. Well, what comes next in the alphabet? A Q. Here's a lowercase r. Next in the alphabet is an S. And so all we've done is we've said, alright, pick one number higher than the number that's assigned to the character. Now print out the character that's assigned to that number. So we've just taken our string and basically shifted all the letters over 1 in the alphabet by using these values right here. Now with this, we haven't actually stored anything, right? We've totally lost our text. There's not really a way to get it back unless we subtract a 1 right here. So instead what we're going to do is we're going to store it into a string. So let's make a new string called encrypted. We'll set it to blank at first. And we're going to add 1 to the value. And then what we're going to do is we're going to say encrypted dot append, so add on to the end of encrypted the character at value. Okay, and then once our whole thing is done, we can print out encrypted. So if I run this, oh, I'm getting an error. And that's of course because strings aren't lists, and so strings don't use append, my mistake. I can say encrypted plus equals character value, keep adding on the new character to the string as it exists already. So now when I go to run it, we get this output right here, just like we had before. So the value of encrypted is this. So we had our string called text. We looked through text and we got each letter. We found the number that was associated to each letter, one at a time. And the number that's associated to each letter, we added 1 to it, and then we put that into a new string called encrypted. So we had our original text that was not encrypted at all, and now we have a new string called encrypted, and we did that by just shifting each letter over by 1 position number. So how could we decrypt this text now? Well, we could just say for letter in encrypted, we could say value equals ord at the letter. So get the number for each letter in this encrypted string here. Then we could just say value minus equals 1. Shift it back to the left, subtract 1. And then we're going to get a new string called decrypted. And that's where we're going to store our text after we've decrypted this encrypted. And so decrypted plus equals the character at value. Oh, we need to print it out too. Print decrypted. So when we run this, you can see that originally our text is programming is so much fun. We looked at each letter, we got its number, we moved that number over by 1, and we put all of those new letters into a string. And then we printed it out. Here it is, this first line on the screen here. After that, we made a blank string called decrypted, and then we said for each of the letter in this encrypted string, all of these garbled letters, take the value for the letter that we're looking at, subtract 1 from it, so just do the opposite of what we did before, move back to the left one, and then add each of those characters into our string and print out the string. And so we've undone the decryption that we had before. Now let's change this up a little bit. Moving it over by 1 is kind of okay, but it wouldn't be real hard to break this string right here, right, to decode that. So instead what we're going to do to make this a little bit more fancy is we're going to put a value called shift. Now we're going to get a value from the user, enter a number from 1 to 1,000, let's say. And instead of just shifting it over by 1, we're going to shift it over by however much the user says to do. Okay, so all we have to do is change both of these values to whatever shift is. So if we run this again, we will see that I forgot a bracket here. Okay, try it again. When we run it again, it says enter a number from 1 to 1,000. Okay, so this is the text we're going to encrypt. I'm going to enter the number 234, and when I hit enter, you can see here is our new string. It's very weird. You're probably not going to decrypt that quite as easily. And there we go, our encrypted text, and we use the exact same value to undo the damage that we had done from before, and there it is, fixed back into its original glory. And we don't have to have a set string right here, right? Text equals input, we can get one from the user. So we'll ask the user for a string. Please enter a string. So when we run it, please enter a string. Hi, I am having fun today. And then it says enter a number from 1 to 1,000, and we'll go 156. And you can see it's converted all of these characters that were in my string, which was hi, I'm having fun today, into all of this garbled mess right here. And then it also decrypted it back into hi, I am having fun today.